Bernick, and I'm here with my coworker, Drop Caputo. And today we're going to show you how you can use Tekton to securely bring your software changes to production. Drop's going to explain the core features of Tekton pipelines, using it to build up a release pipeline from scratch. And I'm going to explain how you can further automate this release process with Tekton triggers by automatically firing this pipeline run whenever certain events occur on a GitHub repository. At the end, we're going to show a working demo of this release pipeline, and we're going to learn what the Tekton Robot Cat says.
Hello, my name is Jerop Kipruto, and I'm a senior software engineer at Google working on Tekton to enable developers to securely build and ship cloud-native applications. We'll explore the foundational features of Tekton pipelines in this section. In the process, we will build a release pipeline using those foundational features. Now, let's look at the building blocks of Tekton and how they fit in with Kubernetes. The first one is a step. This is the smallest unit, which runs a script based on specified inputs to produce outputs, and it creates a container in your Kubernetes cluster. Let's look at an example. In this scenario, we have a build and push step. We give it a name so you can identify what it's doing. Then we specify the container image which we want to pull. In this case, we have a Canico project executor image. Lastly, we specify the arguments that are needed by this container. In this case, we have the Docker file, context, destination, and the digest file. Secondly, we have a task. A task is a Kubernetes custom resource of kind task, and it has to have a name so it can be reused. Therefore, this is a reusable unit of Tekton pipelines. It runs a sequence of steps based on parameters to produce outputs called results, and it's executed in a task run which creates a pod. Some of the foundational features of Tekton task include parameters, which are used to declare inputs, results, which are used to declare outputs, and workspaces, which provision volumes that you can write huge data to. Let's look at an example which uses the step that we just looked at. In this case, we also named the task Canico build. We've specified a workspace named source code. We have a parameter called image, which we'll pull. This task will produce a result called digest. And we're using the same step that we just looked at previously. With this scenario, the task is the reusable unit that can be used in multiple pipelines, which we look at in a few minutes. To execute a task, you need to specify a task run. This task run provides the parameters and other resources that are needed by the task. In this scenario, we can see the Canico build task, which is executed in a task run, and we specified the image. In this scenario, we have a web app demo, and we have a workspace source code, which in this scenario is an empty dar. When we run that task run, we can see an example execution of that, which ran successfully after 25 seconds. And we can see the parameter image, which is exactly what was defined in the task run. We can see a result that was produced, which is the image digest. We can see the workspace that was used. And lastly, you can see the steps that were executed. As you can notice, we actually modified the task a little bit to add one more step that checks for authentication. Lastly, we have a pipeline, which brings all of this together. A pipeline is a directed acyclic graph of tasks, which runs the tasks in parallel or in sequence. A pipeline is executed in a pipeline run, which creates multiple pods through multiple task runs. The foundational features of a pipeline include parameters, similarly to a task, that are used to declare inputs. And similarly as well, it declares results, which are used to declare outputs. And lastly, it also uses workspaces similar to tasks. I'll introduce two more features in pipelines, which include finally tasks that are used to send notifications or clean up the workspaces. This execute at the end of all the other tasks, regardless of whether it was successful or a failure. And lastly, we have a run after feature, which are used to order execution when there are no explicit resource dependencies. So resource dependency is like one task needs a result from another task, therefore we have a dependency in the graph. But then in other scenarios, you may need to order it to execute in a particular sequence. In that scenario, you can use a run after. Let's look at an example where we'll use the task that we just looked at, but we also add on more features. From the very beginning, we have a name, so we can reuse and reference this pipeline. We've named it clone, build, push, notify. We have a workspace called source code and parameters. In this scenario, we have 3 of them: image, repo URL, and the chat webhook URL. Then we also have a results image digest, which in this scenario is actually just a reference to the result of the build task result named digest. When we look at the tasks, we have 2 tasks specified here. The first one is fetch source. And you can see that it's referencing a task named git clone, which we've actually provided in the Tekton catalog. And then this task uses the output workspace, which is referencing the source code workspace from the pipeline level, and a parameter called URL, which is the repo URL. What this task does is actually fetch the source code and write it to the workspace so that future tasks or subsequent tasks can use it or execute upon it. This is exactly what happens in the next task, which is a build task, which is referencing the canonical build task that we just defined in the previous section. And here we have to pass in the image parameter from the pipeline level into this task. It also uses the workspace source code. And here you can also see that we have the run after definition, where we indicate that this task should run after the previous task fetch source. Then we have a finally section. This is a notification task that we've defined, which sends a notification to Google Chat. And it takes a parameter webhook URL and the message, which indicates what happened in the previous task. So in this case, we are sending the status whether it was successful or failure, etc. To execute this pipeline, you need to define a pipeline run, which provides the parameters and other resources that are needed by the pipeline. So in this scenario, we can see that we provide the repo URL, the image, and the chat webhook URL that are needed by the pipeline. We also provide a source code workspace that's needed. In this scenario, we have a volume claim template of 1 gigabyte, which will provision a persistent volume claim that can be used across all of these tasks. We also have task run specs that are providing the service account names to be used by the different tasks. This allows and gives users flexibility to modify execution at runtime. And this is an execution of the previous pipeline run that we looked at. We can see that it was successful after 46 seconds. We can see the parameters that were used, which are exactly what was defined in the pipeline run. We can see the result that was produced, which is an image digest that actually referenced the results from the build task run. We can see the workspace that was used, which is the source code workspace that we defined. And we can see the 3 task runs that were executed as part of this pipeline run, which are the notify, build, and fetch source task runs, which all of them were successful, making the pipeline run successful. In the next section, Lee is going to introduce Tekton triggers, which adds automation into Tekton.
Drop showed us how we can use Tekton pipelines to build up our release pipeline from the ground up. And now I'll show how we can use Tekton triggers in our example to fire this pipeline run whenever certain events occur on our repository. The first core component of Tekton triggers that we're going to be using in today's demo is called an event listener. An event listener is just a service that listens for events and fires some triggers when they occur. So on the right here, I'm showing a webhook that I set up on our GitHub repository for today's demo. And this webhook is going to be sending events to our event listener IP address. When you set up an event listener, you can optionally expose this IP address outside of the Kubernetes cluster that it's running in, and that's what I've done here. A really nice thing about Tekton triggers is this event source is super customizable. So it doesn't have to come from GitHub, doesn't have to come from a webhook. If you wanted to migrate your source control provider, you can do that without having to rewrite any of your event listener pipeline configuration. And it doesn't have to come from a Git repository at all. So you could use a cron job if you're doing nightly releases. You could use a message broker, or you could even set up this trigger to fire based on events published by Tekton itself. I talked a little bit about firing triggers, but what does that actually mean? So you can think of a trigger as a mapping between an event payload and a pipeline run or another Tekton resource that you want to create. On the left here, you can see an example of a GitHub payload from our demo. And here is an example configuration of the pipeline run that we might want to create, our release pipeline, when this event happens. And a trigger just allows you to specify how you want to turn this event into this pipeline run. In our example, I've added a filter. Because the main branch is the only one that gets released into our application, we don't really care about pushes to other branches. So I'm filtering based on some content from the message body to only the events that we care about. You can also map the event payload to pipeline run parameters. So for example, if you wanted to reuse this event listener, trigger, and pipeline run combination for a different repository and its release process, you can do that very easily with Tekton triggers. And triggers also has built-in support for validating GitHub event payloads. So you don't have to worry about events coming from other unknown sources on the internet. Allows you to validate that the events that say they're coming from GitHub are actually coming from GitHub. Let's move on to our demo and see how we can fire our release pipeline when Girop's pull request is merged. Lately, I've been working on a web app for my next big business idea, making animal noises. I want to show you what my web app can do. So I'm going to run it over here in my terminal. And let's make a request to this app and find out what noise a cow makes. My web app is pretty smart. It knows that cows go moo. But there's one feature that's missing from this app. I want to know what noise the Tekton robot cat makes. My app doesn't know yet. Luckily, Girop has been working on a feature that will teach our app what noise the Tekton robot cat makes. In today's demo, I'm going to show you how we can use Tekton to bring her changes securely to production as soon as this pull request is merged. Now that we have our GitHub webhook and our Tekton event listener set up, let's go ahead and take a look at Girop's pull request. Right now, we don't have any pipeline runs running in the Google Open Source Live namespace, as you can see in my terminal on the right. When I merge this pull request, GitHub is going to generate a push event on the main branch. And in response, our event listener is going to kick off a pipeline run in this namespace that will build and publish our web app image. Let's go ahead and merge this pull request and see what happens. As expected, there's now a running pipeline run that's busy publishing our changes. I'm going to let that run and come back to it when it's done. I've gotten a notification on Google Chat that our build has completed successfully. So let's see what happened. We can see that our pipeline run from earlier has succeeded, so I'm going to use the Tekton CLI to figure out the digest of the image that it published. And we can see the image digest right here in the pipeline run results. So I'm going to go ahead and pull this image and run it again locally and see if we can find out what noise the Tekton robot cat makes. So I'm going to Docker pull, Docker run, and let's make a request to our web app. And it turns out the Tekton robot cat says beep boop meow. So I hope this demo has inspired you to try Tekton for secure software delivery.
Now that we've looked at a demo of Tekton pipelines and Tekton triggers, you may be wondering what more you can do with Tekton. Let's look beyond the basics. You can level up your Tekton pipelines using some of these features. You can handle transient failures using retries. You can control execution time using timeouts. You can specify conditions for execution using when expressions. And lastly, you can use cluster resources efficiently using the task run compute resources. Some of the advanced features in Tekton include fan-in and fan-out using Matrix, fetching of tasks and pipelines using remote resolution, and extending Tekton pipelines functionality using custom tasks. Some of the other Tekton projects that you may want to look at besides Tekton pipelines and triggers include chains, which you can use to secure your software supply chain, results, which you can use for long-term storage of execution outputs. In this case, we're referencing the pipeline runs and the task runs. And have the dashboard, which is the user interface for the Tekton resources. We have the catalog and the hub for sharing and discovering your Tekton resources, which makes it easy for you to get up and running quickly. And lastly, you can check out the community project to learn more about contributing to the Tekton project. Thank you.